All right, so today what we're going to talk about is simplifying radicals. And the learning target for today is I can simplify and perform operations with radicals and rational exponents. So hopefully you know your perfect squares, your perfect cubes, and your perfect fourths. Um, Not going to really go over that too much, but I will talk about simplifying radicals. So how do you simplify simplify radicals? So what I do is first thing I look for is um, first thing I'm going to do is I'm going to look for perfect numbers and powers. Okay. Second thing, pull those out. And that's pretty much it. I mean, it's pretty much review. So let's do I don't know. Let's do one like radical 252. All right. So I got to think of, do I know any perfect square roots that go into radical 252? I just tried trial and error. I do know that one of them is radical 36, so radical 36 times radical 7. So what did I do there? I broke it apart. Broke apart, right? So what's the square root of 36? 6. So this is 6 radical 7. So what is that? That's simplify. Okay? That's simplify. It gets a little crazier when you're dealing with things that have like, oh, I don't know, letters or whatnot. So if I take an example like the square root of 121 x to the fifth y to the sixth, well, I'm going to break it apart. This is going to break. I'm going to break it up into 121 x to the fifth and y to the sixth. So I broke apart. Now the next thing you're going to do is ask yourself, is square root of a 121 a perfect square root? That is actually 11, but so I'll put that right there. But what you don't know, because this is square root, this is what's the little number in here is called the index. So you've seen that with like a cubed or to the fourth or to the n. So that little number in there is a 2. So what I do here is this is how I work it. X to the fifth. So what I'm going to do is I'm going to take this. I'm going to say, okay, well, square goes into 5. How many times does square go into 5? It goes 2 times, right? And it has a remainder of 1. So if that's the case, then it becomes 11. And then in here is x squared. And then when it's the remainder is 1. So there's that. Now this guy I'm going to go 2 and I'm going to go into 6. How many times do you go into 6? 3. So that's x cubed, like that. So it's 11 times x squared. I'm sorry, that's supposed to be a y, times y cubed. And what's inside the radical. So this becomes, what does this become? This becomes 11x squared y cubed with radical x in there. All right. Um, Maybe in class we'll do another example of that, but that's pretty much it. Okay. So the next part about that you're going to talk about is adding and subtracting. So when you add and subtract radicals, all right. So how do you add or subtract? Well, it's real simple. First step, simplify all radicals. Second thing is to combine like terms. That's pretty much it. Now, what do we mean by like terms? Like terms would be like the same type of radical. All right, so I'm going to do one like, I don't know, like what if I have, for example, I have negative 5 radical 32 plus 7 square root of 18. So first thing I want to do is I want to simplify. So can I break down radical 32? I think that breaks down to radical 16 times radical 2. And then this guy is radical 9 times radical 2. So break down, break down. So radical 16 becomes 4, so this is negative 20 square root of 2 plus 21 radical 2. So simplify. Now Look for like terms. Negative 20 radical 2 and positive 21 radical 2 is just like if this were negative 20x and 21x, this becomes just radical 2. Make sense? That's how you add or subtract. I mean, I can show you how to do a subtraction one, but I'm probably not going to just for sake of time and the fact that it's the same thing. Just combining your like terms. All right, multiplying radicals. Multiplying radicals is real easy too. So how do you multiply radicals? How do you multiply radicals? How do you multiply radicals? That's a simple process. Step one, multiply. Step two, simplify. So step one is multiply. Step two is simplify. So if we take one like, oh, I don't know, if I take something like 7 times the square root of 3x y squared times 3 times the square root of 15 x squared or cubed y. So step one, multiply. So I'm going to do 7 times 3 times inside the radical 3 times 15 times x cubed times y squared times y. So step one, multiply. All right, what's 7 times 3? Well, that's 21. And then 3 times 15, that's 45. And then this is like a 1, and that's like a 1, so that's x to the fourth y cubed. And then now we simplify. Now we simplify. So, see, this is 21 square root of 9 times the square root of 5. And then I'm going to go 2 going into 4, it's twice, so that's an x squared. And a 2 going into 3, that's a 1 with the remainder 1, so that's a y inside a radical y. So then what's that become? 3 times 21 is 63 x squared y, and inside the radical would be a 5 and the y. Right? So that should be kind of review as well. Let's talk about dividing dividing and rationalizing denominators. So when you divide, well, I guess you should know how to do this, but you've seen it throughout the course of the year. So let's just do a couple quick examples, and then hopefully it makes sense. So there's a few ways you can do it. So like this, for example, 6 square root of 480 over 2 radical 6. Well, you can break down the 6 and the 3. That's mumbo jumbo. 6 and 2, that's a 3. And then this is inside 480 over 6. So 480 over 6. I believe that reduces to 80, so you get 3 radical 80. And then you break down 80. So what's the perfect square root that goes into 80? I think 16 and 5. So then that's 12 radical 5. It's not too tough, right? It even works when you have crazy ones. Like if I take the cube root of 288 j to the seventh k to the fourth over 2 j squared k. All right, first off, I'm going to do inside the cube root. 288 over 2 is 144. 7 and 2, I take those away, so that's going to be j to the fifth and k cubed. Now, do I know the cube root of 144? No, there's not a cube root, but I know my perfect cube roots. I think 8 times the cube root of 18, and then I'm going to do the cube root of j to the 5th cube root of k cubed. So this becomes 2, and then I believe this is still the cube root of 18 because this doesn't reduce. And then how I do this, I do 3 going into 5. What is that? It goes one time with the remainder 2, so that's x to the cubed. Or no, is that, that's a j, not an x. So that's a j, and what's left over is 2 of them, so inside the radical cube root of j squared, and then 3 goes into 3 one time, so that's just going to be a k. So we have 2jk 2jk times the cube root of 18j squared, I think. So it gets a little dicey there, but it's no big deal. A couple more examples. What if you have to do what if you have to do rationalization of the denominator? So what if you have something like, oh, I don't know, 4 over 1 minus square root of 5? And we talked about this. There's something called the conjugate. You gotta get rid of it. You can't multiply the top and bottom by that, so you're going to have to do this. So then this gives me 4 times 1 plus the square root of 5, which will do distributive property. And what happens here? What happens here is that gives you 1, that gives you negative 5. And these guys cancel out. 1 minus 5 is negative 4. And then that cancels. So you get negative 1 plus square root of 5. So if you want to walk that through, you can, and you get negative 1 negative 1 minus radical 5, right? So there's that. And the last bit that we're going to talk about is what's called rational exponents. So you have the rational rules. So if I take like the nth root of x, that's equal to x to the 1/nth. So if I have the nth root of x to the m, that's equal to x to the m over nth root. What does that mean? That means if I have something like p to the 9/2, that is equal to the square root of p to the 9th. And what does that mean? Then I can break this down to the square root of p to the 8th times square root of p to the 9th, or to the 1th. 8 goes, the 2 goes into there 4 times, so p squared radical p. But really the whole idea is that you can use all your rules of exponents. So if you have something like g to the 3/4 times g to the 6th power, you can go g to the 3/4 plus 6 over 1 power. So you're going to go g to the 3/4 plus 24 over 4. So g to the 27th over 4 power. That's it. That's how that works. So I hope that makes sense. And quick little review of exponents. And I look forward to seeing you in class. And may the force be with you.